Hello, welcome again. In this session, we'll solve remaining question of GATE 2018 production and industrial question. Okay. So, starting with question number 41, the preparatory and miscellaneous codes used in CNC part programming and functions are given in the table. Group 1 and Group 2. P01, Q03, RM06, and SF02. Group 2, 1 circular interpolation counterclockwise, 2 end of program, 3 tool change, 4 linear interpolation. The correct combination of code and the respective functions is so G0 is 1 is your linear interpolation, okay, and 003 is your circular interpolation, and G02 is for clockwise and G03 for counterclockwise. M06 is your for tool change and 02 is your end of program. And what is other codes are G0 rapid linear motion, G0 rapid linear motion, G01 linear motion at preset feed rate F, G01 G02 circular interpolation, clockwise G02 circular interpolation, counterclockwise G40 cutter compensation of uh, G41 cutter compensation left, G70 unit entity, G71 unit element, G90 absolute value, G90 incremental value, and M codes are very simple. Codes are M00 program stop, M02 program at M03 spindle on counter clockwise, M04 spindle on counterclockwise, M05 spindle off, M06 tool change, M08 coolant on, M09 coolant off, M30 coolant and spindle on, M30 end of program and device. Okay. So these are the various codes. Okay. Next, a surface of 30 mm into 30 mm of an iron block is machined using electrochemical machining process. Atomic weight and valency of iron is 55.35, add 2 respectively. The density of iron is 7860 kilogram per meter cube. If the input current is 1000 ampere and Faraday's constant is 96,540 coulombs, then the feed rate in per minute is dash up to 2 decimal places. Okay. The atomic weight of the iron is your 55.35. Okay. And valency is your 2. Okay. And the current in ampere is given as 1000 to yeah. Okay, 1000 amperes. Okay, density of iron is 7860 and Faraday's constant is 96540. Now, using the formula for metal roll rate in the electrochemical machining is AI, and that is AI rho ZF, and putting various values. Okay, then we and here the rho in gram per centimeter cube and Faraday's constant in coulomb. So we have to take all the quantity in CGS unit. Okay, so metal removal rate will also be in centimeter cube per second. So this will be 0.0364785 centimeter cube per second. And metal removal rate is nothing but area into feet, and area of the machine surface is just 3 mm into 30 mm into 30 mm, or 3 into 3 centimeter is 3 into 3. Okay, so from it we can find out speed, and the speed is your 0.243 centimeter per minute or 2.43 mm per minute. Okay, so answer is your 2.43 mm per minute. Okay, next, the quality control department of a company maintains C chart to assess the quality of laptop. In this process, 20 laptops are examined randomly. The number of non-conformities observed per laptop in the given is given in the table. this is the table given. Okay, these are laptop number 1 to 20, and number of non-convertibles are also given. Okay, these are the 1 3 7 5 4 10 6 1 5 4 3 6 4 2 7 4 2 9 8 5 2. Okay, based on the data upper control limit for the C chart is, so this is the, these are the number of defects or number of, number of non-defective components. Okay, so number of defective components. Okay, so the upper control limit is given by UCL. That is UCL. Will find out the total number of defective pieces. Okay, for non-conformities. Okay, and divided by total number 20. Okay, number of non-conformities, number of laptops. Okay, or so C bar will be your 4.65. Putting here, we can get upper control limit 4.65 plus 3 root 4.65. So it will be 11.119. So answer is your 11.119. Next, question number 44. The merchant circle diagram showing various forces associated with the cutting process using a wedge-shaped tool is given in the figure. Okay, so this is the merchant circle diagram. F1, this is F1, F2, F1, F3, F4, F5, and F6. Okay, this is the tool, Z phase, length phase, uncut chip thickness. Okay, so the coefficient of friction can be estimated from the ratio of option A F1 by F2, option B F3 by F4, and option C F5 by F6, and option D is F6 by F2. So here F1 is the cutting force, and N is your, sorry, F1 is shear force, and Fn is your normal force. This is your cutting force, this is thrust force. This is force of friction, and this is normal reaction. So the friction force is given by this ratio of F by F6 by F5. Okay, because we from the we know that the normal sorry, the coefficient of force of friction is equal to coefficient of friction into normal reaction, and normal reaction is your F5. So F5 is F5 into mu is your friction force, that is F. Okay, so F6 by F5 is your mu. So answer is your B option. Next, an air conditioner unit is expected to run continuously. The mean time between failure (MTBF) for this unit is 2000 hours, and mean time to repair (MTTR) is 48 hours. The availability of the air conditioning unit is dash up to 3 decimal places. So the mean time between failure is your 2000 hours, and mean time to repair is 48 hours. The total time is 2000 plus 48 hours. Okay. So for one cycle, it is total time 2048 hours. Okay. And actual working time is just 200 hours. Okay. So availability is your actual working time divided by total time. That is 2000 by 2048. So that is 0.9765. Okay. Next. A firm manufactures capacitor using a specified process. The desired specification for the capacitance is 40 plus minus 10 picofarad PF. The process used in statistical control. The process is used in statistical control. If process used is in statistical control, okay. If the process mean is 41 picofarad and the estimated standard deviation is 3 picofarad, the process capability index is, so we will find out that upper process capability index, okay, and lower process capability index, and then we find out the actual process capability index. Okay, so it will be minimum of these two. Okay, and the formula for CPU is just maximum limit minus mean divided by 3 to standard deviation, and for CPL is it is mean minus minimum limit divided by 3 to standard deviation. Okay, so this is your maximum limit is your 50, 40 plus 10, that is 50, and minimum limit is 40 minus 10, that is 30. So from this we get CPU as 1, and from this we get CPU as 1 by 2. So minimum is these two is just 1. So answer is just 1. So active process capability index is minimum of CPU and CPU time. Okay, so answer is 1. Okay, next. A metallic strip having a thickness of 12 mm is to be rolled using two steel rolls, each of 800 mm diameter. It assumes that there is no change in width of the strip during rolling. In order to achieve 10% reduction in cross-sectional area of the strip after rolling, the angle subtended in degree by deformation zone at the center of the roll is option A 1.84, option B 3.14, option C 6.84, option D 8.43. Okay, so this is the roll. Okay, and TI is initial thickness, TF is final thickness. Okay, and this now this distance will be TI minus TF by 2. Okay, because this is TI by 2. Center line of the strip. Okay, this is TF by 2. So this will be TI minus TF by 2. Okay, this is radius of roller. This is angle of bite. Okay, this is again radius, always radius. Okay, and this point is C, this is B, this is A, this is O. Okay, now BC is your TI minus TF by 2. Okay, and OC is your OP minus OC, and OB is your R. Okay, and BC is sorry OP minus this is OB. Okay, OC is your OB minus BC. Okay, OB minus BC. Okay, so BC is your TI minus TF by 2. Okay, so this is R minus TI minus TF by 2. Okay, so OC is your here it is R. It is R cos alpha. Okay, so R cos alpha is your R minus TI minus TF by 2. Okay, so this is your R minus R cos alpha equal to TI minus TF by 2. Okay, putting the values R is your R is your 400. Okay, and TI is your um, TI. Initial thickness is 12 mm. Okay, and the percentage reduction is your PI 10%. So PI minus TF by PI is your 0.1. Okay. So we can find out TF. So now putting the values here, PI as 12 and TF as 10.8, we can find out uh, alpha. So alpha is your 3.14 degree. Okay. So angle of bite or the angle subtended in degrees by the deformation zone. This is deformation zone. Okay, and the angle subtended is your alpha. So alpha is your 3.14. Okay. Next, an electron beam welding process uses 50 milliampere beam current in an accelerating voltage of 150 kilovolt. The energy released per second by the beam in joule is dash up to one decimal place. Assume that 1 ampere is equal to 6.28 into 10 power 18 electron per second, and 1 eV is equal to 1.6 into 10 power minus 19 joule. Okay, so this we have to consider. Okay, now 1 ampere is your this electron per second, and 1 electron volt is this. Okay, so 1 ampere volt is your 1 ampere volt is your multiplication of to 2, and this is your um, this will be your energy joule per second. This is the uh, uh, this is the electron volt. So for one electron volt is providing one electron is providing this energy. Okay. And in 1 ampere there are 6.2 10 to the power 8 electrons. Okay, so this will be your 1.0048. Okay, joule per second should be joule per second. Okay. So 1 ampere of and 1 volt current is now it is 1.0048 joule per second. Okay, bar needs to be bar. Okay. Now your V is given as V is given as 15 milliampere and I is given as sorry I is given as 15 milliampere and V is given as 150 kilowatt. So this is where V into I is where this much and 1 milli and one electron volt is 1 AV is where this quantity. So multiplied by this will get this is where 20226.0.8 in 1 second. Okay. So this is the energy is released per second. Okay. So it's here it should be you can write also here like this. This is equal per second. Okay. And here again we can write energy in joule per second. Per second. Here it is also per second. So answer is energy in 1 second is your 2260.8 joule. Okay. Next, in a machine shop, four jobs need to be assigned to four different machines. Each of the jobs is to be assigned to one machine only at a time. The time taken to complete the job in different machines is given in the table. So this is the machine M1, M2, M3, M4, and these are jobs J1, J2, J3, 4. Okay. This is 15, 13, 14, 17, 11, 12, 15, 13, 13, 12, 10, 11, and 15, 17, 14, 16. In order to ensure that the total time required to complete all the job is minimum. The optimal arrangement is of the job is option A. So we have to select either of these options. We will read out the option after solving the exam. After solving the problem. Okay. So these are the machines. This is the these M1 M4. These are the given table. Okay. So this is assignment problem. Okay. So in assignment problem, what we will do first we will take the minimum number from each column. Okay, and then we subtract from the other elements. Okay. So in the first column, the minimum element is 11. So when we subtract 11 from 11, that will be 0, and 15 from 11, that is 4, and similarly 13 from 11, 11 from 13, 2, and 15, 11 from 15, that is 4. So similarly, we will perform calculation in this column, and in this column, here the minimum is 12. So here will be 0, here will be 0, here will be 1, here will be 4. Okay. So similarly, we can perform in these two columns. Okay. Now, here we can see 0 and here we can see 0, here 0, 0, 0. So number of lines crossing all the 0 is 2. So this is not the optimal solution. So for the optimal solution, the number of lines crossing all the 0 should be equal to the size of the matrix. Here size of the matrix is 4 to 4, so the number of lines should be 4. Okay. So here now again performing some calculation. Now subtracting here we have subtracted minimum element from the column. Here we will subtract minimum element from the row. Okay. So here the minimum element is just 1. Okay. So 4 minus 1 is 3, 0, 3, and 6 minus 1 is 5. So similarly, in second row, okay, second row the minimum element is 0, so it will remain like this, and in third row the minimum element is 0, so it will remain like this. And in fourth row the minimum element is 4, so it will be 0, 1, 0, 1. Okay, so this is the now there are 4 lines which are crossing all the zeros, so this is the optimal solution. Now we can assign the elements. Okay, So first of all, we are assigning first row. Okay, so J1 will be assigned to the 0, that is M2. Okay, and J2 will be J2 can be assigned to this M2 and M1 because but we have assigned J1 to M1 M2, so we will assign J2 to M1. Okay, now uh, similarly J3 J3 can be assigned to M3 and M4. So we are assigning to M4 because J4 cannot be assigned to this M1 because we have already assigned J2 to M1. So J4 has to be sent to M3. So J3 will be assigned to M4. So this is the correct order. So J1 M1, J1 M1, J1 M1, J1 M2. J1 M2, J2 M1, J1 M2, J1 M2, J2 M1, J3 M3, J3 M4, J3 M4, okay, and J4 M2. Option B is the right one. Next, a whole coupling manufacturing company has production capacity of 2,500 units per year. The unit selling price of the item is 150 rupees. The fixed cost of the production is rupees 80,000. The variable cost of the production per unit is rupees 70. If the company wishes to achieve a profit of rupees 20,000 during the calendar year, then the minimum quantity to be produced is, so the unit selling price is your 150 rupees. Okay, and fixed cost is your 80,000. Okay, this is fixed cost. And variable cost is your 70. Okay, and then the profit desired is your 20,000. So this is the simple calculation. So total selling minus total cost is your profit. So selling is your selling price is your S and quantity is your Q. And this is fixed cost, this is variable cost. Okay, and this Q is quantity. So Q is your for P putting P is equal to 20,000 and S 150 and that fixed cost as 80,000 and variable cost as 17 to Q. So Q is your 1250. Okay. Next, the schematic diagram of pouring basin and sprue of a gating system is shown in figure. Both of the molten metal is pouring in the pouring basin is 100 mm. Depth of the molten metal in pouring basin is 100 mm and the height of the sprue is 1500 mm. Okay. Considering cross section of the sprue to be circular, the ratio of D1 ratio of D2 to avoid separation. So this is the height 100 mm, this height is 1500 mm. Okay, this is diameter D1, this is diameter D2. Okay, so now uh, we can find out velocity here by using root 2gh and h will take 100 and we can find out velocity here by taking h is equal to 1500 plus 100 that is 1600. Okay, so suppose this is 2, this is line 2 and this is line 3. Okay, so this is line 1. So velocity of 2 is your 100 means 100 mm means point 1. Okay, so point 1 to 9.81 and the velocity at 3 is your the velocity at 1 is uh, velocity at 1 is your 2 into 9.81 into 1.6 because total height is your 1600 mm or 1.6 mm. Okay, now we have velocity at 2. Okay, and P3 is equal to avoid separation, the pressure at each and every location should be same. Okay, so P3 should be equal to P2. Okay, and V3 is 0. Okay, and Z is there. Okay, so this is the method to find the velocity because okay because the pressure should be same everywhere to avoid separation. Okay, so this is the velocity we uh, either we can apply proposal equation or we can directly find out this. because pressure is same everywhere. Okay, and the velocity at 3 is 0. Okay, so this is V2 and V1 we can find out. Now applying continuity equation, A1 V1 is equal to A2 V2. So V1 by V2 is equal to A2 by A2, A2 by A1, or A2 square by V1 square. Okay, and so the diameter ratio here 1 by 4. Sorry, diameter scale ratio here 1 by 4. Putting out the values. Okay, we have the okay. So d1 by d2 is your 1 by 2. Answer is 1 by 2. So d1 by d2 is 1 by 2 option. B is the right one. Next, in a numerical control NC machine positioning system, the measures of precision are expressed by considering a single axis shown in the figure. So this is a figure given. So if sigma is the standard deviation of the error distribution, then L, M, and N are. So here up to this point there is L, and this from starting on this point this is M, and this is your N. Okay, and this is your L by 2, L by 2. Okay, so L is your accuracy, and M is as is repeating the pattern. So M is your repeatability, and N is your control resolution. Okay, so answer A is the next. In a machining operation with turning tool life CT is related to cutting speed V meter per second, speed mm, and depth of cut D mm. Okay. As P is equal to C, V raised to power minus 2.5, F is equal to F raised to power minus 0.9, D is raised to power minus 0.515. Okay. Where C is a constant, the suggested value of cutting parameters are B is equal to 1.5 meter per second, F is equal to 0.25, and D is equal to 3 mm for the normal rough turning operation. Okay, the B, F, and D are given. Okay, if the operation is performed at twice cutting speed and other parameters remain unchanged, the corresponding percentage change in tool life. So this is the tool life equation. Okay, and B is given as 1.5, F is given as 0.25, and D is given as 3 mm, and tool life is your P1. Okay, putting these values, you can get P1 and C relationship. Okay, now when the speed is changed, in keeping the speed is changed, so it means the speed is your now 3 meter per second, and other parameters are same. F is 125, D is 3 mm. Okay. Putting the value here, only this thing will change. This will be 1.5 to minus 2.5, and 3 is for minus 2.5. Okay. So this will remain same. Another R, sorry, this will there will be change in velocity, and other things are same. So now T1 by T2 will be the ratio of this parameter only. Okay, so 1.5 divided by 3 into minus 2.5. Okay, so T1 or T2 by T1 is your 2 is for minus 2.5. So T2 by T1 is your solving it out. You get T2 by T1 equal to 0.17676. Okay, and to find out the percentage change, so subtracting and adding 1. Okay, so here there will be no effect. So T2 minus T1 by T1 will be minus 0.8234%, or 334, or multiple by 100 becomes it. Percentage decrease in life because of this negative, so it is 82.32%. Okay. Answer is your 82.32%. Decrease in true life with the increase in speed. With the increase in speed. Okay. Next, the annual demand of wrist watches produced on an assembly line is 103,125. Okay, this is the annual demand. The line operates 50 weeks per year, 5 shifts per week, and 7 hours per shift. The uptime efficiency of the line is 99%. The cycle time TC of the assembly line bracketed in minutes per minute is dash up to 2 decimal places. Okay. So the total time available is your 50 weeks. Okay. And there are 5 shifts. Okay. And in one shift there are 7 into 5 into uh, total 7 into 50 into 60. Okay. This is in minutes. Okay. And total uptime, uptime is total time up to 19%. Total uptime is as line efficiency is your sorry uptime efficiency is your 19%. So total uptime time will be this multiplied by 0.9 m. So it will be total uptime. Okay. Now the units to be produced are number of units to be produced are 103,125. Okay. And so the cycle time will be uh, number of units. Okay. Sorry, number total time divided by sorry, total uptime divided by this number of units, that is 1.008 units per minute. Okay, this is cycle time for one component, because for this much of component total time is this, for one component time is this. Okay. Next, in a gear manufacturing company, three orders P, Q, and R are to be processed on a hobby machine. The orders were received in sequence PQR. The table indicates the process time remaining and production calendar due date for each order. Order PQR process time 4, 16 and 6, due date day 20, date 30, date 19. Considering today as day 10 in the production calendar of the holding show. The sequence of the order scheduled using the critical ratio rule is option A PQR, option B PRQ, option C QPR, and option D QRP. Okay. Now the today is our 10. Today date is our 10. Okay, we will keep here. Okay. And due date for the P component is 20, and for due date for the 2 is 30, and due date for the R is 90. Okay. And the process time for P is 4, and this is here 16 is here. Okay. Now the critical ratio is nothing but due date. Okay, due date is your 20 for first component, and today's date divided by process time. So this is due date 20, and this is 10. So 20 minus 10 by 4. Okay, that is your critical ratio. Similarly, we can find it for Q. 30 minus 10 by 16. 90 minus 10 by 6. Okay, so these are the due dates. Okay, so the sequence should be increasing order of critical ratio. Minimum critical ratio is for Q, then for R, then for P. So the answer is your QRP. Okay, so answer is your D answer. Okay. So this is all from the question paper of case 2018. Thank you very much.